This lesson is on dividing radicals. When you divide radicals, you want to look at the number in the denominator. See if you can simplify it. See if you can simplify the radical in the denominator. If not, you cannot leave a radical in the denominator. So we're going to do something called rationalize the denominator, which I'll explain in just a minute. So we're going to rationalize the denominator. And in the process, we're going to make sure we simplify. So let's get started. Number one, if you'll look, we've got a square root of a fraction. Well, you can actually split that into two radicals, the square root of 12 over the square root of 16. And so this takes to the point where I was saying, see if you can simplify the number in the denominator. Yes, the square root of 16 is 4. So we know we get 4 on the bottom, and we should go ahead and simplify the square root of 12 on the top by doing the prime factorization. 12 is equal to 2 times 6, so that's prime. And then 6 is equal to 2 times 3. So that would give me, inside that radical, 2 times 2 times 3. Here's a set of twins. You only get to keep one when you pull it out, so you're pulling out 1, 2. And that means that's all done, but you're still stuck with a 3 on the inside. So this square root of 12 can be replaced with this here. That would be 2 square root of 3. Now, if you look, you want to make sure you're completely simplified. And I can cover up the radicals. What am I left with? The fraction 2/4. That can simplify to 1/2. So you might change it to 1/2, but that radical of 3 stays the same. But this is actually still not simplified. You never want to leave that 1 in front of something, because 1 times square root of 3 is still square root of 3. And then don't forget that that was all over 2. Now we are finally simplified. If you look at this example here, we already have it broken apart, but the problem is the square root of 5 does not simplify. So we've got to do something called rationalize the denominator. So I don't really care about the 2. It's on the outside. All I care about the fact is that I've got to get rid of this square root of 5. So what I want to do is I'm going to do that by multiplying by whatever radical's in the denominator, square root of 5. And you can't change this. It's a fraction, so you have to do it over itself. Because if you actually simplified this, you're multiplying by the number 1. Well, we know 1 times anything is that thing. So, how do we get rid of whatever the radical's in the denominator? Whatever that radical is, you're going to multiply it over itself. That's called rationalizing the denominator. Now we're ready to go. So square root of 3 times square root of 5 can be combined under the same roof over 2's on the outside. And then on the inside, we can go ahead and combine these 5's. Now look, we're in prime factorization form. There are no twins on the top, so I can go ahead and combine 3 times 5, which is 15. Can't do anything with that 2 on the outside. And here is a set of twins, so we're going to pull 1 out. So we're going to do 2 times 5, and that takes care of that, nothing on the inside. So we have the square root of 15 over 2 times 5 is 10. Again, cover up all the radicals and simplify the numbers. Well, there's nothing left but a 10, so that's not going to simplify. So we are done. Now let's look at number 3. With number 3, we want to go ahead and get rid of, you can do x, there's multiple ways you can do this, so that's why I paused. We want to go ahead and get rid of whatever's in the denominator, and there, again, is multiple ways. So I'm going to go ahead and leave this x to the 5th here on the top, and I'm going to leave x to the 3rd, but I'm going to go ahead and multiply them because I don't want a square root in the bottom. So I'm going to multiply them each by x to the 3rd over itself. And so that is, I'm multiplying it times 1. I just can't have that radical in the denominator, so now I'm ready to combine the top. So that means I've got 5 x's here, 1, 2, 3, 4, 5. I've got 3 x's here, 1, 2, 3. Over, I've got 1 radical here, and I've got 3 sets of x's here, 1, 2, 3. 3 sets of x's here, 1, 2, 3. And again, we're looking for square roots, so we're looking for pairs. There's 1 pair, 2 pair, 3 pair, 4 pairs. So that means x to the 4th when I take out 1 of each on the top. Now I'm looking for pairs here. 1 pair, 2 pair, 3 pairs. So that means I'm taking out 3 x's. Those are going to simplify. Now you do need to use your exponential laws here. When you have the same base over itself, you keep the base, you subtract the exponents. 4 minus 3 gives me x to the first. Anything to the first power is x. That would be my final answer here. On number 4, we have that fraction. So what we want to do is split this up. We want the square root of 128 on top. We want the square root of 10x on the bottom. And so, again, multiple ways that you can do this. You could have actually simplified that before going, but that's okay. So we can't have this radical in the denominator. It's not allowed. So on the top, I'm going to have 128. And then on the bottom, I'm going to have square root of 10x, and I'm going to multiply all of that by the radical in the denominator. When I do that, I'm going to go ahead and combine everything on the top. Again, it's not worth multiplying it out. It's going to be 128 times 10 times x. All of that over. On the bottom, I'm going to have 10x times 10x. So let's go ahead and start working on simplifying the top here. I see 128, so I'm going to go ahead and do the prime factorization of that. I see it's divisible by 4. So 4 goes in there 2 times, so that would be 2 times 2 is 4. 32 would be 16 times 2. And then 16 is 4 times 4, which, you know, I can keep going, but I kind of like keeping that because it's a twin, so I'm just going to leave it. So on the top, I'm going to have the square root of, here I've got 2 times 2 times 2 times, watch this, if I did 10, I know that's 2 and 5, so I'm going to go ahead and get this 2 in there too. So that's 1, 2, 3, 4 2's I've used. Next I'm going to go for the 4's. So that's 1, 2, 3, 4 2's I've used, 1, 2, 4's, and I still have a 5, so that takes care of all the numbers on the top plus the x. All that over. I'm actually going to just leave that because watch what I'm going to do here. I'm going to kind of cheat. See, I'm looking for twins, and this is a set of twins. I get to pull out 110. I get to pull out 1x. That takes care of that. On the top, here's 1, 2, 3 twins. So we pull out a 2, done. Pull out a 2, done. Pull out a 4, done. Still on the inside is a 5x. So if we did this, that's 2 times 2 is 4. 4 times 4 is 16. Square root of 5x over 10x. Now we cover up the radical. I have a 16 over 10. That can simplify. I can put a 2 into both of those. 2 goes into 16 8 times. 2 goes into 10 5 times. Now that's it. There's no other radicals, so I'm ready to go ahead and say I have 8 square root of 5x over what I have on the bottom, 5x. Sounds kind of a messy problem. And then finally, number 5. I'm going to go ahead and combine all the numerators, so that would be 9 times 4. And I'm going to go ahead and combine the denominators, which would be 15 times 5. Let's do the prime factorization on the top. 9 would be 3 times 3. 4 would be 2 times 2. On the bottom, 15 would be 3 times 5, and then there's another 5. So let's look for some twins. There's a set of twins. There's a set of twins. We'll pull both of those out. So I pull out 1, 3, done. Pull out 1, 2, done. And then here I have a set of 5, so I pull out 1, 5. So I have a 5, done, square root of 3. Let's clean this up. That's 6 over 5 square root of 3. You're not done. Do you see that radical in the denominator? We still have to rationalize the denominator. Get rid of it, in other words. So we're going to take 6 over 5 square root of 3, and we're going to get just rid of that radical, so square root of 3 over itself. On the top, that would be 6 times square root of 3, which is 6 square root of 3. On the bottom, that would be 5 times square root of, there's 3 and a 3, which is a twin, which can come out, which means that when I have the top, I have 6 square root of 3 over. Then here I have 5 times, just keeping one of those 3's, 5 times 3 would be 15. And now we just need to cover up the radical and see, can that 6/15 simplify? Yes, a 3 can go into both of those. 3 goes into 6 2 times, 3 goes into 15 5 times. So my final answer, I would have a 2 square root of 3 over 5. And then that would be my final answer.